Welcome to regular singular points. So recall, if we have the differential equation, so if we have a differential equation of the form P0 or P0 of x times y double prime plus P1 of x times y prime plus P2 of x times y, is that equal to 0? If we have a differential equation in this form, where P0, P1, and P2 are polynomials, then x0 is a singular point if P0 of x equals 0. Sorry, P0 of x0 equals 0. Here we're going to go, assuming that we have divided by all mutual factors across P0, P1, and P2. So basically, so assuming P0, P1, and P2 do not all three share a common factor. If they did, we could simply just divide through by that common factor until it was no longer a common factor to all three. So we have it's a singular point if it makes essentially the polynomial coefficient of y double prime equal to 0. So now we'll get into what it means to be a regular singular point. So the point x0 is said to be a regular singular point if P0 of x times y double prime plus P1 of x times y plus, sorry, times y prime plus P2 of x times y equals 0 can be rewritten or can be written in the form x minus x0 squared times a of x times y double prime plus x minus x0 times b of x times y prime. Let me move this so I have more space. Plus c of x times y, oops, sorry, that is equal to 0 with a of x0 not equal to 0. So basically, your polynomial coefficient in front of y double prime only has two factors of x minus x0. So this is a regular singular point. So for an example, let's go ahead and show the Legendre's equation, 1 minus x squared times y double prime minus 2xy prime plus alpha times alpha plus 1 times y equals 0 has a regular singular point at x0 equals 1. So note that we are looking at we have essentially a negative x minus 1 times x plus 1 as our factor of y double prime. Then we have a minus 2x times y prime plus an alpha times alpha plus 1 times y equals 0. The polynomial in front of our y double prime has one factor of x minus 1. And the second term currently has 0 factors of x minus 1. So if we simply multiply the entire equation by x minus 1, we will have our 2 factors, our 1 factor, and our 1 factor. So again, we'll multiply the equation by x minus 1. And we wind up with a negative x minus 1 squared times x plus 1 times y double prime minus a 2x times x minus 1 plus an alpha, times y plus an alpha times alpha plus 1. I apologize. That second term should have been minus 2x times x minus 1 times y prime. Then we should have plus alpha times alpha plus 1 times x minus 1 times y, all of that equal to 0. And then we can rewrite this in the form x minus 1 whole thing squared times negative x minus 1 y double prime and plus x minus 1 times negative 2x times y prime plus alpha times alpha plus 1 times x minus 1 times y equals 0. So in this case, my a of x is negative x minus 1. My b of x is negative 2x. And my c of x is alpha times alpha plus 1 times x minus 1. So we do have, in this case, our equation can be written in the desired form, and x naught equals 1 is a regular singular point. So the equation can be written in the desired form. And we have x naught equaling 1 is a regular singular point. So this is just regular singular points in general. We will be focusing on then how we can go about finding the solution sort of near a regular singular point instead of near an ordinary point as we did previously.